Hello, everyone. Welcome to today's session. Welcome, everyone, to today's session. We have a lovely guest today, Simisola, the one and only Chief Software DevOps Engineer from Nigeria, going international. Yes. So, this is the second session on the advanced curriculum. What we're trying to do is to train or create a community of DevOps engineers, both from the beginners to the advanced phase. So in this case, we want to be able to work on hands-on projects in the advanced session. So today will be the topic for today is app containerization and orchestration using Docker. So we've done this before in our first season, the first maiden season of the AWS Nigeria DevOps study group. But this time we're coming back again with um, a more organized curriculum and a more advanced method of teaching, of learning, and of organizing our community. I am once again Ukeme David Eseme, your one and only. I'll be bringing up Sibi on stage. We'll have a few discussions, then we'll go straight to the session. Simi,
Yeah, good evening. Amen.
Mr. Simi, are you there?
Yeah, good evening. Can you hear me?
Yeah. How are you doing?
I'm
How are you
fine,
doing
thank you.
today, Simi?
Very good.
All right. So, are you ready for today's session?
Yes, I am.
Great. So, we'll be waiting for Simi to upload his slides. Simi, I'm still expecting your slides. Then we would start off or we'll kick off in the next 60 seconds. All right. So, we'll be right back in 60 seconds. Thank you.
All right. So let's get to it. I believe we can all see the screen. So I'll be diving into the app containerization. And what we are talking on today, we are focusing on Docker, right? So I have so I'll be very fast in my presentation, so we could have a demo session during this session too. So because this is more advanced, and the assumption I have before now is that we are all familiar with Linux operating system, and also we've had one or two things regarding app containerization, and also had something about Docker. So I will be doing a kind of overview of Docker, then we jump and also explain sometimes in Docker, and also then we'll jump right into the demo session. And like Keme mentioned earlier, focus on this session, we have an app that we are building, and that's the bank app. The repository will be shared, so you can fork the repo and then just follow the README instructions to understand what we are trying to do. So without further ado, let's go in. We'll be focusing on three things, and my presentation I section into three. So we'll be focusing on the what, on the how, and on the why of Docker. What is Docker? Why are we using Docker, and how is Docker used? So those are the three things we'll be focusing on in this presentation. So Docker is an open source project that automates the deployment of applications inside software containers. Docker container wraps up a piece of software in a complete file system that contains everything it needs to run. So majorly, I'll be going fast with my presentation because we have limited time, and the number of slides I have is a bit much. So for me to cover up, so I'll be fast with my presentation. So Docker immediately it's like a wrapper, or it's more or less like a wrapper that you use to package your whole application. So let's say like you have a big bowl of rice and you want to serve that rice to someone. So Docker is like that plate where you put your rice on, then you serve it to whoever wants to eat that rice. So that's what in a more or less explaining to a 5-year-old, that's simply how you put it. So Docker is like you are serving you have your you have your service or your application, you wrap it a package, then dish it to your client or whoever you want to serve the applications to. So Docker is open source, and it is Linux based, and so what Docker is an it's what runs at the operating system level, whereby it interacts majorly strictly it interacts with the operating. So Docker is Linux based, and it runs at the operating system level, and it interacts with the Linux kernel. So I'll be showing us later on the architecture of the Linux system and how Docker plays. So Docker runs unlike your traditional virtual machines, or your physical servers that you have. Docker runs like an application alongside your other applications that you have on your system, making it lightweight, and for you, and also giving you that flexibility to have your application or all your application dependencies in a single box. So all these things we are going to understand later on, where we'll be seeing some pictorial overview. So like I mentioned, we'll be talking on what and why Docker. So why are we talking about Docker? Why are we talking about containers? So take a view like this. What we have here, you have different types of services that you want to deliver to your clients. So you have your car, you have your toxic waste, or your toxic chemicals, you have food stuff, or you have different packages that you want to goods that you want to deliver to. So the question now comes in, which how are you going to deliver these goods to your end customer? So then the options now come. So are you going to transport it by sea, by air, or by rail, or whatever way you want to transport it? How are you going to transport it? And how are you going to ensure that whatever you are transporting, it gets to the customer in the same way where you have your application, so, or where you have like your service still remains intact, it's still working at the same the same way it was working while it was maybe when you produced it to where you are now delivering it. So this issue of you delivering the application. So let's now come back to development or tech. So you begin scenarios whereby developers or software programmers tell you, oh, the application is working on the test environment, but when it gets to the production environment, it start malfunctioning, meaning, oh, if dependency is missing or a package that the application requires is not present in that environment. So and so all these dependency issues that you get with applications that, oh, that this library is missing, this dependency is missing. So it gives rise to what we call a matrix from L, because you don't know how you would package all these applications. You don't know you know how you package it, but one way or the other, due to human error, you might miss out a dependency, which in the adverse effect, it would break your application. So we also have it to so same way we have for application or for goods, we also have it for our services or for your applications that you build. You have your website, you have your database, you have your APIs and the rest. And you have it across multiple cloud. You have it in different environments, your test environment, your production environment, and your even if you're having it in the cluster. So you have it in different environments. How do you ensure that your application remain in what says has this sanity that yes, it is still operating, the application got your end goal is that your application works the same way it works in your test. You expect it to work also when it gets to your pre-production environment and also when it gets to your production environment. So all these dependencies issues are as to my production, my test, my dev environment, are they all the same? Are the dependencies, are they all there? Are my application working the same way? All these things also is what we are calling the matrix from here, because you have dependencies scattered here and there. And maybe there was a new feature that your developer implemented in its own environment, but on getting to the production environment or the staging environment, that dependency is not there. So because of this issue, that is what gave rise to Docker. So that's what give rise to container, to say, okay, since we want to be shipping applications, we want to be shipping goods and services from one place to other, why don't we just package them in what we call a container? So that same approach whereby we package goods and services into containers, that's the same approach Docker uses. So it gives you the flexibility to package all your application dependencies, all the service that your application would need, all the libraries that your application would need. It packages into what we call a container, and then so you can have that container in your dev environment, and and also have it in your production environment. So meaning that with that your container, the same way your application works in your dev, it is also working the same way when it gets to your production environment. So there's no issue then. So Docker eliminates what we call this matrix from L. So Docker eliminates this issue of, or say, oh, dependencies is missing, or this package is not installed in your dev, or is not installed in your production or your staging, or majorly your libraries are missing. So so like I mentioned, Docker eliminates what we call the matrix from here. So let's go a step backward and explain the Linux operating system. So in your Linux system, you have your hardware on every either physical or virtual system that you have. There's an hardware, then on top of that hardware there's an operating system, then on top of that operating system kernel, then you have your software applications running on it on a Linux system, right? So on that Linux hardware, you now, so it's those softwares that are now different. So you have the one for Red Hat, you have a software that is for CentOS, you have the one for Debian, you have the one for SUSE OS, and the different types of Linux operating systems that are out there. So they all ride on all your software, they all ride on the same operating system kernel. So is this technology that Docker 2 now brought into play, whereby your Docker sits close to your operating, works straight with your operating system kernel. So it runs alongside your other applications that you have on your system, on your Linux environment. So it interacts directly with your operating system kernel. Okay. So I would be jumping some of the terms I have here because of our time. And then, so the majority is what we have as a Docker, how Docker works, So we have your you have your, so if you could see, Docker sits alongside your, works alongside your operating system, then it packages all your applications. So you could have a Node.js application, a database application, a messaging, Redis messaging application, a orchestration application, or whatever it is, or Ansible, or as the case may be. So you have your application running alongside um running alongside your operating system, so making it very lightweight. And also, so in that, and those applications, they are all separated. Those applications, these containers, they are all separated from one another. So uh for because of time, I would want to jump to a demo session, so we could see how Docker works in real life. So, but before that, let me just explain. So, for your hardware, or your virtual machine, or your physical systems that you have, this is majorly like the orchestration of what you have. So, like the way people do it before is, oh, they want to speak, or they want to run an application, they set up a new environment. So they set up a new virtual machine. You have an hardware. On top of that hardware, you have an operating system that runs on it. Then so for you to now, so they buy this big hardware, say a system of 1 terabyte of disk, and then put in, say, 256 gig of RAM on top of that system with a very high computing power. So on top of that system, they now put what we call a virtualization software, which is what we call the hypervisor. So that hypervisor is now what's on top of that hypervisor. That's where you now create your virtual machine. Example of an hypervisor is your VMware, which you have, or virtual, or Microsoft Hyper-V. Those are one popular, at least popular hypervisors that people use. People use. So, unlike containers, so the bottleneck that you will see, if you see the what I have here in utilization, the size of space, and also the time it takes for it to boot up, you see that it's all on the high side, unlike when you have it on your container side. So, because of time, I will be jumping to a demo session. So I'll be showing you Docker in real life. So, so I have here um, my VM. I have a VM set up for this environment. So my screen is coming up. My screen is coming up shortly. So on this VM, so we have what we call. So what I've done prior to now was to install Git. I also install Docker on this VM, and also install the Node.js application on it. So just to verify, if you type Git, This is to verify that Git is installed, and also I have Node installed on this. I have Node 9.63 installed, and also npm 9.63 installed, and I also have Docker installed. So, so like I mentioned, Docker gives you a way to package your application and run those application in. So what we'll be doing is now is the first thing is so how do we get your Docker to run your application? So what we have what we call Docker images, which are templates, or which are look, let's say this which are templates for your applications. So they are like just like you have for a system, a physical system. You have for a physical system, your Docker gives like, and you want to clone that system in another system, in another hardware. What you do is you create an image of that system, then you take that image, then you clone it to that new system. So same way you have for Docker. So Docker, you have your image, which is all the information regarding, or all the information regarding your application, that is being packaged as a template. So with that template, you can now run um your application. You can now build your application and run them on your system. So for this demo, so before we go further, I will be cloning the Git repository, which is coming. Let me confirm the previous repo. Let me delete. I want to delete the previous repo which I have cloned. So I've deleted that. So I want to clone the repo afresh. So if you recall our last section, we talked about Git, and we talked about also planning on what you need to do. So for this project, we've drawn out a roadmap of what we want to achieve and what technology that we are going to be using. So we are sticking with the AWS cloud. And so I have my VM running, and on that VM, I've permitted some ports on my security group to open my VMs to the world. So I permitted port 80 and port 3000, which is the default for the application. So I want to clone the repo. Uh, So I'm cloning the repo now. So I have the repo cloned into my local environment. So like we have in our repo, the first thing, if you view the README file, so let me just cut it out. So the first thing it says we should do is you clone the repo. Then the next thing is you navigate into that repo directory, which I have done. I'm already in that repository directory. Then it asks that we should ensure that Node is installed on this system. So as for this our system, we already have Node installed. So the next thing it says we should do is we should run npm install. So which I'm going to do. Since this is a Node application, so we are running npm install. So this will install all the packages that the application needs for it to run. So while this is going on, So what is happening? What this is happening is it is installing all packages that my application requires and all other dependencies majorly that my application requires. So another thing that it also mentioned that so after we run npm install, then we can do npm start to start our application, and our application will be open on localhost 3000. And also, so because so what once it does that, so I'm going to open up a new window whereby we can, so we'll be seeing some of the things that our application is performing. Comment. Let me get my server IP. All right. Okay, so I'm in my environment now. So if you could see, it has finished installing all dependencies. So I can run. So although it is flagging that there are some vulnerabilities and I can fix them with npm audits. So but I just want to run our application because so all these the vulnerabilities and vulnerabilities that it is flagging are because the node package that we are running is, if you could see from some of the errors that it is giving or some of the warnings that it was when I did npm install, it is telling me that, oh, this package has been deprecated, this package is deprecated, this package is deprecated. That means I need to update them. So an npm audit fix do um, would rectify this, but I don't have time for that. So I just want to start my application. So when I start my application, so if you could see, my application has started. So and it is going to tell me what port my application is listening on, and so I should be able to access that port in the browser. So now it is telling me that my application is running. So from the second window which I opened earlier, meaning I can call this URL and I should get a response, which I am getting. So for we that are in the chats, I will drop the URL of the app, or Kemi, if you can help me to drop I'm dropping the IP, so you can help me to paste this in the group, so anyone can just access the application on this port 3000. So if you could also see from here, from the other, so it is telling me that my application is running and it is running on port 3000, and it's also on the network, meaning the application is exposed on this server with on that port 3000, meaning anybody can access it on this port 3000, right? So the next thing that that I would want to do now is, okay, now that I am sure that my application is working in my own environment, how do I move this application to another environment for it to work? So what I now need to do, this is where now Docker now comes into play to say, oh, you have the application developed on your environment and it is working as expected, and it's working as expected, working as expected, then I can then meaning that I can now package this application and run it in my and then I need to ship my application to my developer or for my own development environment to my either my staging environment or pre-production environment, then move it to my production environment as the case may be, right? So what I now do next is I write a Docker file. So, so here you see a template of the Docker file which I've written. So what my Docker file does is this. So I'll be explaining it from line by line. So for Docker files, what we so for every just like your GitHub, right, whereby you put as a repository of all your codes, Docker files or Docker images, or I mean your Docker images, which is the template of your application, all resides on they have a public repository which is called a Docker Hub. So it's from this public repository called Docker Hub whereby people now publish so some companies can say, oh, they don't want to use the public Docker, or they can decide to create their uh, own Docker image repository and manage it themselves, right? But for this scenario, for this our course, we are using the public Docker hub, which is hub.docker.com. If you go to that website, hub.docker.com, you are going to see your all your applications. You are going to see all the repositories, all the public repositories and different repositories of different applications templates that you can access. So because and one thing again, when you are packaging your Docker application, right? One thing that you need to look at is the size of your image after you build that image. So for this, we are using because we know application is running on Node, so we are using the Alpine version 3.1. We are using Alpine, we are using Node 19 and using the Alpine version. Because the reason why we are using this version is because Alpine is very light, it's a lightweight Linux package. So you know your application is running on a Linux environment. So Alpine gives is a lightweight Linux um, templates for all Docker images, most of Docker images, and then the node. So we have Alpine node, which node is installed on that on these templates, right? So it's from there we are going to build that we are going to build. So what Docker does is it builds your application in layers, right? It builds it layer by layer. So the first thing is we set the more or less the roots or the foundation layer, which is that your application is running on Linux and Node is installed. So, like when we were doing the npm install start or before we started, what was in the README was that you should have npm installed on your system. So this has taken care of that first step to say npm is installed with this with this line. It has taken care of npm install. So the next thing we have to do was to specify a directory or to cd into our directory. So now we are specifying the directory where in our own application here we are calling in Docker, you call it your work directory. That means that's the directory where your application is going to run. Then So ignore this line now. I'll come back to explain it. Then the next thing we did was we did run npm install. So in Docker, for you to run any command in your Docker environment, or to if you are building your image, you have to specify either if you go through the Docker repository or Docker docs, you are going to see all these commands, and it explains them more in depth. So your run is to execute a command for your Docker. If you are building your Docker image, then you have your copy, then you have your expose. Your expose is to so before I come to expose, so then we do um, we didn't do this while we are building the when we are running the application. We didn't run the Docker. We didn't do build. So build is when you want to publish your application to the world. When you want to publish your application for everybody to see, that's when you run npm build. So like I would go back to that if time permits. I will go back to my application and run an npm build. So you see why we are running all these commands, right? So the next thing we did was from what. So let me go back again. So the next thing we now did was we copy. We did dot dot. So what this dot dot is signifying is you are copying everything from the current directory you are in to the destination directory, to your work directory, which is this slash app folder. And then you are running npm install inside that folder. So meaning that we've cd into from your readme, we've cd into the directory. We are now running npm install because all our application package are inside that folder now. Then we are now building the application. So the build is for you if you want to publish your application for people to access. So you build. You know, when we did npm start, normally we did npm start before, but now we are doing a build. A build is would now package everything. If your application has started successfully, then you can now say, oh, you want to ship that application for someone to test. Then you do npm build for that application. Then you send the person your build folder, because this is a npm, a node package, is a node application, right? So the next thing we now did was so normally we could have said, oh, we want to now expose our application and ignore these two lines and expose our application. But what we discovered over time was when you do your npm build finish, your application size is very large. So we now did what we call a multi-staging. In there's Docker has what we call a multi-staging, whereby you build an application from an existing application, or build an application from an existing application template, a former build step. Let me put it like that. So what we did was we now run we did from. So if you know from in the first instance, I said um from node node 19 Alpine system, right? So this was my initial root image which I was building on for. But now I've not changed it to Engine X, because now I noticed that Engine X image is a lighter image, and my application, I want to expose my application on port 80. So this is now creating a multi-stage build for my application. So what I now did next was to now copy everything in my build directory. Recall I'm in my app directory, my app folder. I'm now copying everything from that my build folder, my app build folder. I'm copying it to the Nginx public directory, right? Then I'm now exposing my application on port 80, then running a command to say, okay, start my Nginx. If it was, so let me just run this. The repository is there, so you can quickly go through it and we would all understand better. So I would run this. So to build my Docker image, I run docker build. So I could say docker build, then put a dot. A dot means that, oh, it's in the current directory I am in. Look for any file that has docker with the name docker file. So I could build this directly and it will build my application for me. But best practice is if you want to build your application, you tag your application. So you see why why it's advisable you tag your application. So you won't have so there won't be issues whereby you have so many build and you don't know which, you have so many images and you don't know which of the image is what. So while this is running, I'm going back to my previous command window where I have my application running. So if you could see from here too, when I cloned the repo and I did npm start, it now said to create a production build, I should do npm run build. So recall in my Docker file, I have that npm run build, which is running as at now. So while this one is still building, so if you could see here, okay, if you yeah, this is it. So it is running that npm run build because I'm packaging, I want to deploy, I'm making my application production ready, right? So if I should come here, okay, I want to stop my application. So my application has stopped. So I can run npm build here. So if you see from here, see, look at the current folders that we have. So it has created that build folder for me. So I can now run this npm build. So no, let me list the content of my build first so you would see. Go back. So majorly this is all the asset of what you would see in your public folder or your public HTML folder or your public application folder that is exposed to the world to access. So this is building the application for me, right? So now if you go, so now that I've built my application finish with in my Docker image finish, now I want to see the Docker image here. So I do Docker images. So it's going to list the image for me. Sorry, I'm coming. So it didn't list that image. Oh, yeah, I get. So the thing is, I've built an image earlier on. So it is carrying those image. Let me delete those image. So this is what I was trying to show you. So now if you could see this now, when I did Docker build, my image does not have a name, does not have a repository name, it does not have any tag. So by default, by best practice is if you want to build your image, you give your image a tag so you can understand what that image is. So you can say tests, maybe you are doing tests. So if I specify ordinary tests, then I put my Not so when you are building, not this dot at the end of it, because that is what is telling us that it is where your image or Docker file is. So now it has built a so now see it has tagged that image. So it has tagged that image. So it built the image, giving it the name test. Because I didn't specify any version, any tag for my image. It will give automatically give your image the tag latest. But if I say, oh, I'm still building maybe 1.0, I'm not sure of what I did. Maybe that's what is required. So I can tag it 1.0, then build it. Or then if I make changes in my code, then I want to build the image again, I can tag this one maybe 1.1. It's going to be so if I do Docker images, you see now I have different version of the image. So I have the one of 1.1, 1.0, and then the one of latest. So I can now decide now to now run my application. So what I want to do now is to show you the one of the like I showed in my slide, that you can have multiple applications running on a single host. All you just have to make sure is that your applications are running on different ports, so they are not conflicting one another. Because I'm going to be exposing my application ports to the world. So to run my application, I just put Docker run. So IFP is to specify a port for your application. So the first port I'm specifying port 80 from my application. So the internal port my application is exposed on in my Docker file is also port 80. Then I'm now running my application in a detached mode. So meaning that this dash D would run it in the background. Then I specify my image name, which is this. So a container, so like I forgot to mention, a container is a running version of your image. In a container is a running version of your image, while your image is a template of your application with all the dependencies in it. So I want to run 1.0. Oh, sorry. My image name is tests. So now image 1.0 is running. So I want to run another one, which is the one on for image 1.1. So that is also running. So if I don't specify any tag latest, or I could say, so now if I do Docker PS is to list the containers that you have running. So you can see I have 3 containers, all running on port 81, port 82, and port 80. So in my security group, I have these ports already exposed to the world. So if you, same way, if you type in wait, let me confirm that I have those ports exposed to the world. Oh, sorry. I already have port 80 exposed to the world. So I'm just going to modify my security group. So if you could access my application on port 81, you will see that you get a response. If you also specify port 82, you get a response. If you specify port 83, I mean port 81, 82, and 80, you all get a response. So if I do, so one thing in Docker again is, so because I've loaded port 81, let me confirm. I've loaded port 81, right? So if I do Docker logs and I specify my container ID, which is for 81, so I can see request that, oh, someone has made a request to my application. So if I want to do for check for other applications too, if someone has actually made a request to them, as at now, nobody has made a request to my to my application running on ports. Which one is that? Dot cab. The one running on port 82. So if anyone in the chat or anyone in the live audience can go to this URL, you would see uh, is that my IP. I'm dropping the IP in the chat. I'm dropping the IP in the chat. So if you go to that URL, you will see that there's a request, the my logs, because now I'm following the logs of this container. Yes, someone has just hit that URL. People are hitting that URL. So if you could see now, requests are coming to that container. So that I can confirm that, oh, my container is getting requests and things are happening on it, right? So more or less, this is Docker in would I say is not up to an hour, but this is more or less Docker in an hour to that we've talked about. So we've talked about how Docker works. So we've shown that's what we have done here. We've talked on why and what is Docker. So I don't know if there's any question in the live audience, so we could take that.
All right, guys. Thank you so much for thank you, Simi, for doing justice to Docker. You've done a fantastic job as usual. If you have any questions, please let us know. We still have the live IP address on the screen. You can hit the URL and see if you can access the application. If you can, give us a thumbs up or um, give us some indication on the chat so we know you're following up. Um, so Franklin is saying that my image is taking too long to build. Um,
Okay. Uh, are you on this? So Franklin, so it is so one thing that it takes for your image to make it takes time is, one is the environment you are running your image from. So if you are running it on your local system, factors that causes your image not to build fast is, one, your internet connection, then second is your system speed. So like I am running on a 4 gig RAM system, which is hosted in the cloud, meaning that there's no application running on it. So why that's why my own image is very fast, and the speed on the server itself is more than your average is more than the average internet that I'm even using at home. So I don't think my internet is up to the bandwidth of my system is up to 1% of what my server is running. So those are the things that might cause your image to not build fast. And another thing is also the base images you are using. So if you could see from the repo, if you clone the repo, if you could see what we have there, we have the image in multi-stage building. So because we noticed when we built the image in the first time, what we noticed was that the image was very large. So for us to reduce the size, that's why we now did it in the multi-staging building. So
All
is there
right,
any question from
fantastic.
any other person?
Fantastic. We have one more question from Kennedy. Kennedy is saying, how do we handle a Docker build where the Docker file and the source files are in different directions, different directories?
Yes. So there in the Docker what's the name? Docker docs. If you go to the build section, there's I'll drop an example now of my file is not in my current directory, but it's in another directory, right? So you can specify your directory where your Docker file is, and Docker is going to pick up your file from there, and it's going to build that file for you. Come on, let me get that.
All right, fantastic.
So
I think we
let me
have.
sh-
Okay,
you let me share something in the. So this is from Docker repository. So can you help me share this?
okay. All right. Franklin, we'll come back to your question in a bit. Let's post this. So you can also check the Docker documentation for more information about this. But I think this has done justice to that question. The syntax showing on the screen. Um, so Afolabi Franklin is saying, thanks for the insight. I am trying it on my local, but it but I will try it on EC2 later. Fantastic. Give it a try on EC2. We try as much as possible to encourage our community using AWS services as much as possible. You can spin up a, a T2 Nano or a T2 Small for your free tier service. And if you're just spinning it up for just a very short period of time, it shouldn't cost a lot of money. Okay.
And don't forget to delete. Don't forget to delete your instance once you are done.
Yes, don't forget to terminate or stop your instance once you're done, because that's kind of like a novice mistake. I have also made that mistake. You leave it running, and then the next thing you're accumulating costs, and at the end of the month you start to beg AWS, asking for a plea that you didn't know what you were doing. I was a victim of that. So please try as much as possible. Once you're done, remember to terminate or stop your instances. Um, so Edmond Godwin is saying, please, is it possible to get the PowerPoint materials?
Yes, definitely, it's possible. I would share that in the group. Um, just confirm you are in our group. So we'll drop that in the group chat also. Drop it in the group chat.
All right. Edmond Godwin, are you a part of the group? Just signify in the chat so we'll know how
If
we
you are
can
not,
pass this.
we'll drop the group link also. So you
Okay.
could.
All right. So we'll drop the group link. Um, Kennedy is saying it's a great session. I believe you, Kennedy. Yes, it's been a great session. Simi has done justice. Yes. So you can specify the directory of your source on your Docker file definition and either use the copy and move commands to move them to your directory. So this is another way to solve the problem in which Kennedy asked initially. We would share the group link on the channel. So if you're just joining us from the first time, you can join the WhatsApp group. I'll send the link in a bit. All right. So Franklin is saying, thanks for the time. It was nice being here with you all. Thank you, Franklin, for attending and being attentive to the session. So I have dropped the WhatsApp group link on the chat. Join the group. We'll be rounding off soon. Kevin Tui. I hope I pronounced that right. How best can you set up a CIC for this? Um, Let me answer that. We would have a CICD session in the future. We can't cover that now because today is just for containerization and orchestration. If you join the group chat, we have a curriculum that covers most of this. I think CICD would be in like next month. I think so. I would have to check and confirm. Any other questions before we call it a day? All right. With no questions, we'll give a round of applause, a virtual round of applause to Simi Sola for doing a very good job. And we can take the Simi. Do you have any assignments for them?
Hmm, that's true. I did drop an assignment for my beginners class too. I will drop both. I am unfairly tomorrow for both the beginners and also for the advanced session. I'm going to drop assignment for both of them tomorrow unfailingly. So if you
All
are in
right.
the group, you should get an assignment.
All right.
I
So
am tomorrow unfailingly.
okay, so you will get the assignment tomorrow unfailingly. Thank you everyone for attending today's session. We'll be having the beginner session next week Wednesday 8 p.m. and then the advanced session next weekend, Saturday, same time, 8 p.m., same time, same station, probably with a different speaker. I think we'll be having GT. GT is also a pioneer in the industry. Thank you so much for coming. Please have a wonderful evening. Bye.